This video help will show you how to use the NORM.DIST function necessary for questions 1 and 2 in self-assessment number 9. The spreadsheet is set up with the information from question 1, where the birth weights at a local hospital are normally distributed with a mean of 112 ounces. I've put that value in here, and a standard deviation of 15 ounces. And we're asked to find a few probabilities. In part A, we're asked to find the probability that a randomly selected infant weighs less than 117 ounces at birth. So our value for X is 117 ounces. We're going to use the NORM.DIST function to calculate this. We start with equals. I can start typing. I want the NORM.DIST function, so I can just double click on that. The first argument is our X value, which in the question is 117 ounces, comma, we need the mean, 112 ounces. You could either type 112 or reference the cell where you have that information, comma, we need our standard deviation next. Again, you could type 15 or you can reference that cell like I am, comma, and then we do want the cumulative value, so we'll type or double click on true, close the bracket, and the NORM.DIST function always calculates the probability that our randomly selected, in this case infant, has a value of less than or equal to the data point that we put in. So the probability that a randomly selected infant weighs less than 117 ounces at birth is 0.6305, and so on. I made a note here that the question is asking for that probability, less than. So there's nothing else I need to calculate. My probability I'm interested in is the probability that that function returned. In part B, we'll have a little bit more work to do. In part B, we're asked, what is the probability that a randomly selected infant weighs more than 125 ounces at birth? So I start by using the NORM.DIST function again. In this case, my value for X is 125. The values for the mean and the standard deviation haven't changed. And I always want the cumulative distribution function. So again, true, and close the bracket. But remember, what the NORM.DIST function does is it returns the probability of being less than or equal to that data point. So in this case, what this value is, 0.806, is the probability that an infant weighs less than 125 ounces at birth. But our question asks, what is the probability that a randomly selected infant weighs more than 125 ounces at birth? So we need to do an extra calculation. Just like you did in class, we take 1 and we subtract the probability from the normal distribution function. So 1 minus this value in B6, enter, and the probability that a randomly selected infant weighs more than 125 ounces at birth is calculated here. In the final question, we're asked, what is the probability that a randomly selected infant weighs between 107 ounces and 140 ounces? So we need to use the normal distribution function for both of those values, 107 ounces and 140 ounces. These will be two separate calculations using the same method as above. So starting with either X value, in this case I'll do 107, the same mean and standard deviation for the whole question. Always again, true for the cumulative distribution function. So here I've calculated the probability that a randomly selected infant would weigh less than 107 ounces. And in the cell below, I'll do the same for our other value of 140 ounces. And then just like in class, to calculate the probability of being between two different values, we need to subtract the larger probability minus the smaller probability. So equals the larger probability minus the smaller probability. And the probability then that a randomly selected infant is between 107 and 140 ounces is calculated here. You were asked to format your probabilities to 3 decimal places, so I'm going to highlight those cells. And there's a number of ways you can adjust that. I'm going to use this little button here to get 3 decimal places. When you're done that, you can insert your text box and write your final statements for all of those questions, part A, B, and C. Once you've practiced this, you can use the same skills to answer question 2 in your self-assessment.